Okay, so let's continue. So it's raining outside, and okay, and heavy raining. So 3.5, we're gonna talk about the trig derivative. Okay, and in this section, the two key result. Okay, I think I'll say here is to knowing that the derivative of sine of x equals cosine of x. Okay, and the derivative of cosine x equals negative sine of x. Okay, those are the key to support all the extended trig derivatives. Okay, no matter how complex, it's all starting from here. Okay, and also remember that sine x squared this. Okay, so this is one of the very classical identity from the trig function here. And so make sure know this. So derivative of sine equals cosine. Derivative of cosine equals negative sine. And where is those two from? I can, again, guys, it's all starting from the limit definition, okay? So f of x equals sine of x. So following the limit definition of the derivative, you evaluate the sine of x plus h minus sine of x over h, let h approaches 0. Of course, we can have a lot of identities to like to rewrite this. Sine of x plus h can be rewritten as sine of x cosine h plus cosine x plus sine of h, you know, and then we do some technical construction, and then we can get the conclusion. This limit equals cosine of x. Okay, so that's the key. Okay, so no matter what, know this too, for sure. Now let's take a look at how do we handle. I mean, the light is not that good. Okay, how do we handle the derivative of tan of x? Okay, how do we do that? Well, let me give you some hint. If I rewrite tan of x into sine of x over cosine of x, okay, and do you see that when we take the derivative of this format, do you realize that we actually can use the quotient rule to deal with that, right? Remember, because this is exactly a fraction format or rational format, right? So using the quotient rule, as you remember, the bottom, which is cosine square of x, and then on the top, remember it's a log, right? Times d height, derivative of sine x equals cosine of x, okay? Minus height times d log, right? The derivative of cosine x equals negative sine of x. Okay, so as you can tell, guys, on the top, what do you have? We have cosine square x minus minus become plus, plus sine square of x over cosine square of x. And on the top, remember the property, right? The identity, that a equals 1. So the derivative of this is going to be 1 over cosine square of x or secant square of x, okay? So as you see that, guys, as long as you know those two and rewrite the tan into sine x over cosine x, apply the quotient rule, you can easily get a secant square x, okay? In fact, you do not need to memorize all of this, okay? Again, knowing the quotient rule can always help you get to here, okay? So this section should be a okay, so how do we handle the derivative of cotangent x? Well, same thing. Rewrite it as cosine of x over sine of x, right? And then we can apply the quotient rule to deal with that, which is sine square root of x over, remember low d high, right? Remember that? So we're gonna have it's low times d high, which is negative sine of x, okay, minus high times d low, right? Which is a cosine of low d high minus high times d low. The derivative of sine of x equals cosine of x. Well, let's see. We have negative sine square x minus cosine square of x over sine square of x, okay? What you can do is on the top, we can factor this negative out. So we're gonna have negative sine square of x plus cosine square of x over sine square of x. Remember, inside of the parentheses equals 1, so it's negative 1 over sine square x. And then, do you see that it's negative the second square? Easy, right? Very easy. Okay, so let's look at the last one. Okay, how do we figure out the derivative of secant square, secant x? Well, rewrite it as 1 over cosine of x. Take the derivative. Again, you can apply the quotient rule. So it's cosine square of x, low d high, times the derivative of high, which is 0 minus pi, times d low, negative sine of x. Well, this is what we have. We're going to have sine of x over cosine of x squared. And you see, guys, this is what we can do. And do you see this is actually equals tan of x times secant x. So that's the derivative, okay? If you simplify. Again, guys, this section is a very straightforward section, okay? And the key is to know that the derivative of sine x equals cosine x. The derivative of cosine x equals negative sine of x, okay? So I'll stop here and then I'll see you in the next section, okay?